Okay, this reaction is weird, and we're going to balance in both acidic and basic solution. The reason this is weird is this is a disproportionation reaction. What does that mean? Let's go through and identify all of our oxidation states. So bromine over here is 0. Here, oxygen is -2 and hydrogen's +1. Over here, bromine is -1. Here, oxygen is -2, 6, +5. So if you notice, bromine is both oxidized and then reduced. When one element is both oxidized and reduced, that's called a disproportionation reaction. So how do you handle those? It's really not bad. You just put the same exact thing in both of them. Like what I mean by this is both the oxidation half and the reduction half. Start with bromine. You're like, can you do that? Yes, because when you add the two equations together, you just end up adding them together anyway. So in the oxidation half, Br with a 0 charge is going to Br with a +5. So that's going to be BrO3 minus. On the reduction half is Br goes to Br minus. Okay, so balance like normal. 2 bromines, again, be careful with that. So you need a 2 here. So that's 6 oxygens. So 6 waters. And that's 12 hydrogens. So you add 12 hydrogen ions. That's +12. That's -2. So this is a +10 over here, and this is 0. So I have to add 10 electrons. Down here, don't forget to add the 2 again. Here, charge is -2. Here it's 0. So add your 2 electrons. So in this case, this is 10, this is 2. You can leave the top one alone. Multiply the bottom one by 5. So it becomes 10 and 5 and 10. And then the only thing that we can cancel out here are the electrons. So then add it all together. And then in acidic solution, it would be this. 6 waters plus Br. You add those together. Br2 and another Br2. 6 Br2 goes to 2 bromide. Put those out of order. That's okay. 2 bromides plus 10 bromide ions plus 12 hydrogens. And you should notice something, and this almost always happens with disproportionation. 6, 6, 2, 10, 12. We can simplify that. So our actual coefficients here in acidic solution are going to be 3. Always check to see if you can simplify. 3, 3, 1, 5, and 6. And then let's check to make sure everything works out. 12 hydrogens. No, that's 6. 6 hydrogens, 6 hydrogens. 3 oxygens, 3 oxygens. Why did I put that 2 at the top there? That goes down there. There's 6 bromines. There's 1 plus 5 more is 6. And then the overall charge here is 0. This is -1, -5, which is -6 plus 6. So then it's 0. But you saw this OH minus at the beginning, so maybe it was in basic solution. So if it's not told to you, assume acidic. But just in case it said it was basic solution, what do we do here? Add 6 hydroxide ions to both sides. And what will happen when you have 6 hydrogens and 6 hydroxides? You get 6 waters. And so then these 3 waters would now be gone, and you'd be left with 3 on this side. And in basic solution, you would have this equation. 3 Br2 plus 6 OH minus goes to BrO3 minus plus 5 bromide plus 3 waters. Okay, let's count one more time. 6 bromine, 1 plus 5 is 6. 6 oxygens, 3 plus 3 is 6. 6 hydrogens, 6 hydrogens there. Overall charge here -6. Overall charge here -6. Balanced.